This episode of Raw Green is brought to you by OBI, a sustainability consultancy firm specialized in life cycle assessment and decarbonization strategies. At OBI, we've designed our new Chief Sustainability Officer package to empower SMEs with comprehensive ESG solutions at a fraction of the cost compared to traditional solutions. Our entry package includes a full ESG report covering scope 1, 2, and 3 emissions, a tailored emission reduction strategy, access to GRI certified software, and more. What sets us apart? Affordability. Our goal is to make sustainability accessible to businesses of all sizes. Contact us for a free consultation at info@oneob.com or through the links provided in the description. And now, get ready for the next episode of Raw Green. Ciao! In today's episode, we're diving into a pressing environmental issue: the staggering number of abandoned oil and gas wells worldwide. An estimated 29 million wells are left idle or abandoned, between 2 and 3 million in the US alone, 40% of which, according to the EPA, are leaking methane. These abandoned wells pose severe environmental threats, from contaminating water supplies to degrading ecosystems, emitting methane and other air pollutants. The consequences can be terrible. Plugging these wells is crucial to mitigate these risks. However, the high cost of plugging presents a significant barrier, averaging $75,000 per well, and in some cases over $1 million. It would take $193 billion and over 100 years to plug them all, to avoid millions of tons of CO2 equivalent emissions released in the atmosphere. But even with these challenges, there is hope: repurposing abandoned wells for geothermal power generation. This innovative approach not only addresses environmental concerns, but also unlocks the potential of renewable energy sources in unexpected places. The guest we have today is a published researcher at the Tyndall Centre for Climate Change Research at the University of Manchester. The research recently published by her and her team is a comparative life cycle assessment on repurposing oil and gas wells for geothermal power. Please welcome Dr. Jingyi Li.
Thank you, Francisco, for having me here and for the very comprehensive introduction about me. Hello, everyone. I am
Ciao, doctor.
Jingyi. I'm a postdoc. Yeah, ciao.
Ciao.
Ciao,
how are you
ciao.
doing?
Good morning.
Good morning. How are you doing?
I'm doing great.
Yes?
Great.
Good. Well, thank you for being here. As I was saying to you pre-recording, I wanted to thank you and blame you at the same time, because since I came across your research, I'm basically still excavating into a rabbit hole about abandoned oil and gas wells with the specific purpose of repurposing them with geothermal power plants. It is such a very interesting topic. But before we jumped into the main topic, if you don't mind, give us a brief introduction about yourself and your area of research.
Yeah, sure. So I'm a postdoc, currently working at Tyndall Centre for Climate Change Research at the University of Manchester. So my basic training is in chemical engineering, with a specific focus in energy and the environment. Then I move on to my PhD research. Basically, my areas of interest include like climate change, sustainability, life cycle assessment, circular economy, and like you said, geothermal energy as well. That's the highlight point. So my research looks into how we can use the oil and gas wells to convert them into geothermal power generation. In doing so, I was using the circular economy framework, and there's one strategy coming from this framework called repurpose, which means we can use the same product or service or process to be used in a different function compared to its original one. And when we look into the tremendous potential, like you just mentioned about the oil and gas wells, how much they are going to be abandoned or they're already abandoned, we saw that's a really big potential that we can transfer those oil and gas industries into a green industry by generating the power from the geothermal energy embeds in the underground. So basically, this research, I use a methodology called the life cycle sustainability assessment. When we talk about the methodology, I want to divide into two parts to give a bit brief introduction. One is the sustainability. So basically, when we talk about sustainability, we obviously need to consider all of the three pillars. One is the environmental, the second one is economic, and third one is social aspect. And we can divide the whole power generation process into different stages. For my project, to take an example is exploration, construction, operation, and maintenance, and then eventually it's end of life. So we can give specific like environmental impact evaluations, for example, for 18 different impacts indicators, and just to specific to a particular stage, like for construction stage, this climate change potential equals to whatever is the number there. So we can provide very detailed analysis and track back what are the materials or energy actually contributed to this particular environmental impact. That's the life cycle assessment amazing part. Yep, that's a brief introduction of my research.
Okay, cool. Well, why then don't we start from the end of life? And by end of life, I mean the abandoned oil and gas wells. So while doing some research, I was absolutely shocked by the amount worldwide, besides the US, but literally worldwide,
Yeah.
29 millions. And this is a figure that it is extremely an approximative, because so many remains undocumented. From oil and gas companies that went past, that they didn't declare the closing of the wells. So many of them, I found it out, are even unplugged. So they continue to, they're abandoned and unplugged. So they continue to emit with terrible environmental and also human health consequences. So if you can please start with that part. Why technically a oil wells gets shut down, maybe the life of an oil well, what are the reasons, besides the economical output of an oil wells, what are the reasons to shut them down?
Yeah, what you mentioned about the legacy problems after shutting down the oil and gas wells is deemed to be a very important issue and commonly reported all the way around. The reason to shut down the oil well can be various reasons. Here I mentioned a few that maybe the top two or three. So when the companies shut down the oil and gas well, probably due to it's not going to be commercially valued, which means, like in my research, I proposed one of the cases utilizing the semi-abandoned oil and gas wells to generate geothermal electricity, which means referring to the wells still in operation, but in their production stream, it contains too much water together with the oil. So the company probably feel like it's not going to be cost effective or less profit going to be made. And then they will consider to shut down. However, if you continuously to maintaining or this kind of operational well produce less expected amount of oil from this well, the cost is huge. So company probably will make a trade-off in the economic consideration, as you said, to just to plug it or unplug it, just leave it there to move to another side. Another reason is there could be some operational or maintenance issue that the oil well's integrity condition is not meeting the requirements to continuously provide large amount of oils from here. So compared to moving to another side or plug it, they choose to like not going to operate it anymore. They just shut it down. And there's gas leakage emissions. If you didn't properly maintain it or plug it, like you said, that's deemed to be a big issue. And apart from methane, there are also other emissions could occur in this process, such as hydrogen sulfide, carbon dioxide, and nitrogen oxide, etc., etc. Those kind of chemicals can also do harm to the surrounding environments and also the adjacent aquifer, not just to the atmospheric emissions.
Yeah, I know. I've seen some incredible videos of little pool of bubbling water, not even actually right next to the abandoned wells, but like maybe 10, 20 meters away, where basically you see the crack into the wells below ground, that it is basically expanding around. And it freaks you out because it is who knows what's inside there and what are the short and long term damages to that. Okay, so and then in your study, you work on this basically three assumptions, which are correct me if I'm wrong, a fully abandoned double well, a fully abandoned single well, and a semi-abandoned, I don't remember if it is double or single well, to be honest with you, compared to two wells, okay, semi-abandoned two wells, compared to a brand new geothermal power plant. And the target of the study, it is to analyze the environmental impacts throughout the entire life cycle of these four hypotheses, of these four hypotheses per kilowatt hour produced. Right?
Yeah.
Okay. Now break
completely
it down,
correct.
please. Thank you, Professor. Thank you so much. Okay. Can you please break it down? So first of all, what are the differences between the single and the double? Okay, and if you can give just a brief panoramic on what are the major intervention for each of this different plant.
Great. So in a short answer, the biggest difference between the conventional geothermal power plant and the repurposed systems is the differentiations in terms of the drilling requirements. For repurposed systems, they have much less drilling requirements compared to the conventional one, because the well bores coming from the legacy oil and gas wells are existed there already. You don't have to do massive drilling to explore a completely new site to see what is happening there in the underground. But for the conventional geothermal power plant, you need to do survey first to look around the areas to detect whether you have the geothermal source. We can say it's a hydrothermal reservoir, which means you have the hot water downstairs, not downstairs, sorry, underground.
Okay.
And then
to your
Love
neighbor.
that.
Yeah.
That's a swimming pool.
Yeah. A thermal bath. Yeah, you can call it thermal bath.
Summer bath. That's a
Uh,
good name.
or your neighbor's sauna. I
So
mean, I can't keep going. Your neighbor's sauna too will work.
so
Okay.
when you when you find the hydrothermal resources, you can start the new drilling. And for conventional idea, people tends to do the geothermal power plant exploitation or development in tectonically active regions, which um, which are the areas have high geothermal heat gradients, so a high temperature. So countries such as Iceland, Turkey, Indonesia, they are very well known for the heat gradient. So people will do the geothermal drilling there to get out the heat from the underground, and then fit into whatever the overground power generation unit. There are several technologies. I won't jump into the jargon, but I just want to mention one of the very amazing technology called organic ranking cycle.
Mhm.
Probably will come across this later as well, I believe so. It can utilize a much lower temperature from the underground and use that heat to exchange with an organic working fluid, which has a very, very low boiling point. So this kind of fluid can extract the heat. We extract it from the underground and then to drive the turbine and then generate the electricity, and then to do a loop. Just the organic working fluid will be stayed in the organic ranking cycle loop.
So you
Can be
recite
repeatedly
basically.
used.
It's a continuous
Yeah,
flow.
in the
Okay.
cycle. Yeah, it's a
Which
continuous flow.
which seems a very good solution for let's say areas where you don't have that tectonic activity,
Yeah,
that a hydrothermal activity, like in
yeah,
Iceland. Okay. Okay.
yeah. Theoretically, I mean, like we don't consider the economic aspect. It can generate the electricity when it's like the temperature reaches 65 degrees C or so. You can do
Okay.
that. So it's very, very low for electricity generation. Give you a comparison, the traditional one probably requires you to reach 180 or 300
Wow.
degrees Celsius. Yeah, for a dry steam power plant. So this actually massively could make the technology widely applicable in a lot of regions in the world with this kind of technology advancement. So that's for the conventional geothermal power plant. So we drill the new wells, and they're deep wells. Totally is over 6 kilometer, 2 wells. And then we use the organic ranking cycle for the above ground geothermal power generation, like what I just introduced, how the technology work.
Mhm.
That's the conventional geothermal power plant. When we move on to the repurpose systems, like you said, there are 3 different setups. One is the completely abandoned wells with 2 wells. So basically what we need to do is to reopen those wells to check the integrity or the quality of the well bore, whether it's good or not. But in my research, I made an assumption that we just need to replace the cement and also the integration material to make the well more functional again. So we just don't do like a very optimistic analysis that after you reopen the wells, you can still use whatever is there. We just take the material depletion consideration into its worst case. So we replace everything. And then we can install the organic ranking cycle unit on the above ground if there are still water downstairs. Like in my assumptions for these repurpose systems, especially for the fully closed wells, we need like conventionally there are water downstairs and we can just directly use it. Obviously, there won't be too much qualified wells, but this is how we propose to this approach. But there are like further advanced technologies that we can just completely not using the water. We just use the heat coming from the well bore, which is the case I put in the single well. So we can just install a downhole heat exchanger. So it's a vertical one compared to the normal we see like in the industrial side. It's maybe like horizontal one. But we can insert the heat exchanger into the single wellbore and let it do the heat exchange by using the heat coming from the surrounding rocks, and then to do the organic ranking cycle unit in the above ground for electricity generation.
Wow.
And that's the fully abandoned ones. Yeah. And for the semi-abandoned one, like I briefly talked about it beforehand, we can just use the oil and gas well still in operation, but close to their end of lives due to high water content. So we must say the wellbores are not due to any technical issues. You have to shut it down. It's still working well. It's just because less oil is producing through these wells. So instead of we ask the oil and gas industry to shut it down, they can directly transfer it to the geothermal power generation via just install an above ground organic ranking cycle unit to generate the electricity. So in this sense, they don't need to do any abandonment process.
Yeah, you save on materials, you save on the plugging costs, obviously, which actually that you will still have them because, I mean, there is also a duration in which the well can work properly while producing geothermal power. So that will take a little bit of time, but nonetheless, it is a wonderful thing to extend the life of an environmental damage that at the end can be repurposed for doing something clean. To do something clean. Please keep going. Sorry to interrupt.
Exactly. Well, so if we can just utilize this, whatever is active oil wells or abandoned wells, we at least can eliminate some of the concerns from the oil and gas industries from in terms of like the high plugging costs, like you mentioned. One is that. The second is the potential continuously gas leakage due to the not well plugged technology or lack of looking afterwards. So they can directly do the operation and maintenance to make the well can be functional for geothermal power generation. And this kind of cost, they're not going to be like close a business, but they're actually extending their best business. That's the idea, actually. Keeping the products or process in use is one of the basic principles in the circular economy.
Yes.
We found this is what actually triggered us like the interest.
Yeah, beautiful. Sorry, Doc. Let me ask you something, because likewise you were saying before when a geothermal experts they scout around for the proper area to dig holes in a tectonic area. Likewise, also for the production of hydrocarbons, oil companies they look for specific areas. Which I mean, I'm not a geological expert, but it is similar with underground activity. Okay, and even after the well is being plugged, there is the risk that due to that underground activity, the walls of the well of the hole down they get cracked, so you can still have leakages of n number of harmful gases or materials. So what is, let's say, a good estimation that you can say, okay, we are going to repurpose this well. How long can it last?
Great. This is a very important question because it also, again, aligned with the economic consideration. Like after we do the investment in the repurpose systems, how long we can generate the electricity and how long we can ensure the wellbores continuously be using. In my research, I give a quite, I'd say, conservative estimation for me, after consulting several experts from the oil and gas industry, or the pilot plants they already implemented in France, it tends to be around 10 to 20 years at that time because it's a pilot scale and also people are not fully aware of the technology. So it's quite conservative estimation. And eventually I used the 15 years in my study to estimate the repurposed systems. But recently, after I attended a seminar given by Seraphy Energy, they could say like after the repurposing to restore the integrity of the well and trying to minimize more interruptions or interventions of the original, or I would say existing well bores. They use that a closed loop system, like we're not requiring the water from underground. We just use the heat from the surrounding for the heat exchange, and then the electricity generation. It can last around 30 years. So it's like literally a normal new geothermal power plant can last. So it's for the well bore's life. But obviously, in my personal opinion, I think probably the earlier to transfer into the geothermal power production might be better to make it last for longer for green electricity generation.
Yeah. And okay, I am going into, let's say, comic science here right now. But would it be possible? I've seen videos, and I mean, I've never been to Texas, or you have this incredible huge amount of land with, I don't know, hundreds of thousands of these wells operating. But would it be possible to develop a grid based on, let's say, multiple wells connected one to each other? And I'm thinking about this for n number of reasons. And the first one being, okay, we're going to repurpose our soon-to-be in operating wells. We have to connect it to the grid and to the transmission grid. And these places, they're not very close to civilization. Sometimes they're really far away in very remote locations. So you can have the most amazing technology, but it has to make also it has to be economically feasible. Would it be possible to create microgrids?
I think this idea is very interesting and fantastic. Like you mentioned before as well, I found it's your original idea. I won't claim for the credits. I think that's a very wonderful thought.
I told you I'm blaming you for all of this, so you're gonna bear the consequences.
So I will briefly talk about my own idea because I'm not an expert in terms of saying very scientific ideas regarding the microgrids, but I do think it's a very good solution, especially when currently we're facing about the scale issue of these oil and gas wells. That, like what you said, we need to scale it up, and one of the ways to scale them up is to assemble several wells together to generate a higher production flow rate, and so that we can have a higher heat amount to be exchanged for power generation. So if there's some microgrids that which can store the energy into the microgrids and then use it maybe like locally or like just on the side for other industries nearby, that would be a wonderful idea to solve the problem that transmit just a tiny amount of energy we generated from maybe just 2 or 3 well bores to the main electricity grids and reduce the transmission emission and also the costs.
Yeah.
So that's I say it's a wonderful thing, and because you are generate from this side and you're using in your local areas, and in the future if you see like for the further like development, there probably people will live surround and nearby. So I say like this is a very good idea to supply maybe for the community in the future as well. If you see, like, I'm currently, like, for my postdoc project, sorry, a bit advertisement for my current project.
Please.
I'm still looking into repurposing, but instead of repurposing the oil and gas wells, I'm looking for repurpose the coal mines for generating the mine water heat from the underground. And in the UK, there are around 1/4 population are living above the abandoned coal mines. So it means, like, if we can fully utilize the water from the coal mines, you can just heat up maybe millions of the houses or the buildings, office blocks,
Really?
etc., etc. So that is possible, and there are projects already in operating in the UK. When the Gateshead heat pump from the mine water energy is already in operation. And not just in the UK, in France, in Netherlands, they also have this kind of projects. And after using mine water in the district heating network, they can expand for multiple low carbon heating resources, such as hydrogen, or in the future,
Hold on.
integrate like
Calm down.
nuclear.
Pump the brakes. Pump the brakes, because here I foresee another rabbit hole right there. Pump the brakes. You're saying
That's also very interesting. Yeah.
yeah, it is. So you're saying that from coal mines, you're able to extract water, warm water, that can be used
Yeah.
for heat generation and in some cases for the production of hydrogen. Did I got it right?
No.
Okay, thank
No,
you.
hydrogen is from other sources.
That would have been an incredible rabbit hole. Okay. Okay.
No, that's not possible. No.
I don't know. There was some sort of exchanger that was able to produce hydrogen. No. Okay. Okay. Please go on. Sorry.
Yeah. Sorry, probably I made this not very clear at the beginning. Like, the hydrogen isn't, like, further sources can be used in the district heating network, because the nature of the district heating network can integrate multiple sources in the central energy center, and they're using the heat they generated from whatever the sources to supply to the heat users. That's what I mean. So it's actually a very aspirational technology. And also these are benefited from the repurpose idea in the circular economy thinking.
Yeah, very interesting. Very interesting. Well, definitely have to know more about that. So let's go back one second to the geothermal. What we're talking about 15, potentially even 30 years duration. What are the maintenance costs and emissions involved into repurposing a oil well into geothermal power plant?
Right. So because they're in my economic study, they're quite all allocated to level. And on my hand right now, I don't have the specific figure, but I can give you a rough idea about the percentages they are taking. For the conventional geothermal power plant, the most costs are coming from the exploration and construction. It can contribute over 50% of the total life cycle cost.
Wow.
But for the repurposed wells, like repurposed systems, because we highly eliminated or mitigated the drilling requirements, the cost associated in the construction stage has been massively reduced. So mainly the operation and maintenance cost dominated in the total life cycle cost. It probably can reach to 80 to 90% of the overall cost of the repurposed system for the daily maintenance. Because for the construction stage, we only need to install the organic ranking cycle. And for my project, because of the install capacity of the repurpose, the systems are fairly low. So probably like less cost for installation, and the capital cost invested in the organic ranking cycle unit will be much less. Yeah.
So what can you give me a ballpark figure in terms of price per kilowatt hour produced between the two? Or an idea, maybe, what would be the difference between the two?
You mean from the construction to operation?
How much would I sell my electricity from the brand new geothermal power plant versus the one from the repurpose? Would there be any difference? If yes, would it be a big difference or a small difference in terms of price?
Well, to be honest, my research didn't look into the supply price, so this part I couldn't give a proper answer. But from what I observed in terms of the cost analysis I've done, is if you can massively reduce the construction and exploration cost from the drilling,
the CapEx less,
you can, you can actually lower down the cost. Maybe we're just using the repurpose systems, using the semi-abandoned oil well case compared to the fully abandoned 2-well case. It can reduce 77% of the overall cost.
Whoa.
Because you are reduced, like mainly there's no drilling required for the semi-abandoned one. However, this is just based on the 20 kilowatts, and we are assuming like for the to reopen those wells and also to do some drilling requirements to restore the borehole, it's actually cost a lot as well. But for semi-abandoned, we did nothing for the underground. That's why the cost has a really big difference. Yeah.
Well, that makes even more sense. What we were saying before in the continuation of the operation for that well before the oil company plugs it or abandons it, makes even more sense. Fantastic.
Yeah.
And we're talking about, okay, here, this is a hot topic. We're talking about a system or an idea or a project that could help savings millions of tons of CO2 emissions and other, obviously, environmental disasters. Would carbon credits be a additional solution that could help incentivize more to kick off actually the repurposing wave needed?
I believe you are actually asking whether this can do a bit in phasing out the fossil fuel industry in terms of the climate change. So, well, coming into this topic, I say like to tackle the climate change, obviously we need to phase out all the fossil fuel industries. And however, we couldn't let them go without provide a very good plan for them. For example, where are they going to? And geothermal power generation from these wells provide one of the solutions. Obviously, it's not all the oil wells suitable to be repurposed. And what you mentioned to giving the incentives of the carbon credits is one of the very good ideas that definitely we would encourage the governments or the policymakers to implement. But there should be a more funding schemes to just targeting to help the transition of the oil and gas industries into geothermal power generation. And two factors very matters right now. One is the scale of the plant, how much they can generate from the repurposed systems. The second one is when we need to do this, because we are living in a very constrained carbon budgets right now. If we want to tackle whatever climate change impacts, we need to have very systematic changes right now. So it means more transition should be done from the oil and gas or fossil fuel industry in general perspective. And to transfer into the geothermal power generation is one of the most direct answer or obvious answer. You need to look into what are the conditions of the wellbores you're having. and what kind of the production flow rates you actually can achieve. Obviously, these are all based on the conditions that the site temperature, what kind of temperature you can achieve. If power is not the solution, then you can try direct the heating from these wells. That's also one way to go, but it's necessary. Like you said, we need to move towards to tackle the climate change.
Well, yes, and Doc, you need to have, you and I and millions of other peoples around the world can have all the best, let's say, initiative and solution at heart, try to solve the problems. But in reality, you need that financial incentive. Otherwise, you won't.
Definitely.
Otherwise,
Yeah.
renewables, if there wasn't the wave of incentives in Europe during the 2000 and 2010s, we wouldn't be in this situation. It is all a butterfly effect. China would have not started the massive production of renewable energy equipment, both solar and wind, and so on, battery deployments, you name it. Okay, so everything starts from somewhere, and the economical part, it is definitely the biggest trigger you can have. So if you have something that makes sense environmentally and economically, it is a win-win for everybody. Let's face it.
Exactly.
Look,
Yeah.
Doc, this has been crazy interesting. Thank you so much for sharing your research. I again want to blame you for everything for my past 2 weeks. I got
Thank you
work
so
to
much.
do.
I accept all the blames.
I got work to do. Okay. You gotta send me more stuff about the coal, the repurposing of the coal mines. Okay, maybe that's another episode to do together.
I will.
Okay.
I will. Keep you posted.
Thank you so much, Doc. It was a pleasure chatting with you.
Thank you so much for having me.
I'll talk to you soon. Take care.
Take care. Bye.
Bye. Thank you for joining us on this episode of Raw Green, brought to you by Obi. At Obi, we have designed our new Chief Sustainability Officer package to empower SMEs with comprehensive ESG solutions at a fraction of the cost compared to traditional solutions. Our entry package includes a full ESG report covering Scope 1, 2, and 3 emissions, a tailored emission reduction strategy, access to GRI certified software, and more. What sets us apart? Affordability. Our goal is to make sustainability accessible to businesses of all sizes. Contact us for a free consultation at info@oneob.com or through the links provided in the description. See you at the next episode. Ciao.